Ensembling of SVM and Decision Tree for Prediction of Heart Disease. Abstract cardiovascular sickness is a major reason of mortality in the present lifestyle. Heart disease is accountable for deaths in all age groups and is common among males and females. A good solution to this problem is to predict, patient's health status will be forwarded to the doctors. So, doctors can start treatment much sooner, which will yield better results. For this reason, machine learning techniques are used. Nowadays, machine learning plays an important role in the medical domain, which includes development of new procedures for medical, handling of patient data and records and treatment of diseases. Machine learning holds incredible potential in diagnosis of various diseases. The research focuses on heart disease diagnosis by using machine learning algorithms and ensembling of SVM and decision tree. Keywords: machine learning algorithms, decision tree, support vector machine, SVM, heart disease, ensemble learning model. Introduction. The healthcare sector is an important industry which offers a value-based care to the millions of people, and it has been early adopter and greatly benefited from the technological advances. Playing an important role in patients' care, billing, medical records, and today's technology allowing healthcare specialists to develop alternate staffing models, IP capitalization, providing smart healthcare, and reducing administrative and supply costs. Nowadays, machine learning plays an important role in the healthcare industry, which includes the development of new procedures for medical, handling of patient data and records, and treatment of diseases. In healthcare sector, machine learning helps to analyze the different data points and outcomes, provide risk scores, precise resource allocation, and has different applications. Machine learning algorithms can detect patterns associated with disease and health conditions by studying thousands of different healthcare records and other patient data. Machine learning in healthcare sector has its ability to process large number of datasets beyond the scope of human capability and reliably convert analysis of data into clinical insights that aid physicians in planning and providing care, ultimately leading to better outcomes, improve care at lower costs, and increase patient satisfaction. One of the serious issues in medical care is the rising number of heart disease patients. Heart disease is one of the most prevalent diseases that can lead to death, disability, and other economic crises in patients who suffer from heart disease. Each year 17.5 million people are dying due to CAD, coronary artery disease, in this world, according to World Health Organization, WHO, reports. Popular known common type of heart disease are heart failure, hypertensive heart disease, coronary artery disease, heart murmurs, congenital heart disease, pulmonary stenosis, cardiomyopathy, and rheumatic heart diseases are some of the heart disease types that can be caused by many factors. Due to digital technologies are rapidly growing, healthcare centers store huge amount of data in their database that is very complex and challenging to analyses. So that using data mining techniques and machine learning algorithms play vital roles in analyses of different data in healthcare, hospitals, and other medical centers. Prediction is a good methodology in healthcare centers where clinicians do not have more knowledge and skill, as well as where there are no specialists. For instance, such clinicians may give their own decision that may give poor result and lead the patients to death. Prediction of heart disease is used for automatic diagnosis of the disease and give sufficient qualities of services in healthcare centers to save the life of individuals. Prediction technique helps to make an accurate decision for the stakeholders, particularly for specialists to give reasonable decision to treat patients. The healthcare sector has been an early adopter of and benefited greatly from technological advances. Nowadays, machine learning plays an important role in health-related realms, including patient data and records and the treatment of the disease. The rate of heart disease, liver disease, and kidney disease is increasing at an exponential rate. In this busy lifestyle of people, having all fast food in lunch break and getting back to working and sitting has pushed an over the edge lack exercise and less active, and these factors boosted the rate of the heart disease, liver disease, and kidney disease to an unfortunately high percentage. 2 Literature survey. In this section, we are going to discuss basically the previous works on heart disease. A work related to heart disease. Untitled tried various machine learning and deep learning techniques for detecting the heart disease and also performed hyperparameters tuning for increasing the results accuracy. Neural networks achieved high accuracy of 78.3%, and the other models were logistic regression, SVM, and ensemble techniques like random forest, etc. For reducing the cardiovascular features. SING-ETAL2 used generalized discriminant analysis for extracting nonlinear features, a binary classifier like an extreme learning machine for less overfitting and increasing the training speed, and the ranking method used for all these was Fisher. The accuracy achieved was 100% for detecting coronary heart disease. Arrhythmias classification was done by Yoghaubi et al. 3 for heart rate variability. ASL et al. 4 used Gaussian discriminant analysis for reducing the HRV signal features to 15, and 100% precision is achieved using the SVM classifier. Rajagopal and Ranganathan 5 used 5 different dimensionality reduction techniques which are unsupervised, linear and nonlinear, and neural network is used as a classifier for classifying cardiac arrhythmia. Zhang et al. 6 used the AdaBoost algorithm which is based on PCA for detecting breast cancer. Negi et al. 7 combined uncorrelated discriminant analysis with PCA so that the best features that are used for controlling the upper limb motions can be selected, and the results were great. Avendano Valencia et al. 8 tried to reduce heart sounds to increase performance by applying PCA techniques on time-frequency representations. Kamenke et al. 9 tried a new method for different medical images reaching an accuracy of 83.6% when trained on 200 images by using PCA-KNN, which is a scale invariant feature used in medical images for the scaling purpose. Ratnasari et al. 10 used a gray level threshold of 150 based on PCA and ROI, all of these used for reducing features of the X-ray images. Heart disease is very fatal and it should not be taken lightly. Heart disease happens more in males than females, which can be read further from Harvard Health Publishing 11.3 proposed system. This system aims at presenting the end users a personalized healthcare system with asset of data mining techniques. Overview of 5 main steps that research framework constitutes. Data collection. Data collection process involves the need for selecting appropriate data for analysis and obtaining effective knowledge by performing diverse data mining techniques. Pre-processing. The pre-processing is avoiding missing values either by replacement or remove missing value from the data set. Feature extraction. It is the process of finding input features for a predictive model which involves removing irrelevant features that don't contribute towards the model. Classification. Classification is performed using various machine learning algorithms which includes SVM and decision tree algorithms. Prediction of disease. From given data predicting whether the user is having disease or not. 4. Methodology. Methodology for the system is as follows. The dataset is collected from the online resources UCI repository and Kaggle. Machine learning model building. The main purpose of the study is to build the machine learning algorithms and find the best machine learning algorithm. A decision tree. Decision tree learning is one of the most widely used techniques for classification and it is supervised machine learning algorithm. Its classification accuracy is competitive with other methods, and it is very efficient. It has flow-like tree structure and it works on the rules and conditions. It mainly has the attributes, branches, and terminal node. SVM. Support vector machine, SVM, algorithm are a class of extremely popular classification models and supervised machine learning algorithm that can be used for building both regression and classification models. SVM algorithm can perform really well with both linearly separable and nonlinearly separable datasets. The working of SVM is given below. See ensemble learning. Ensemble learning algorithms is a machine learning technique. It combines the several base models to produce an optimal predictive model. Ensemble is supervised machine learning algorithms. This helps to improve the machine learning algorithm's results by combining the several models. An ensemble learning is a set of classifiers. It is constructed with the given algorithms and for each new examples are classified by combining the prediction of every classifier from the ensemble. These predictions can be combined by taking the average, for regression tasks, or the majority vote, for classification tasks, as described by Breman 12, or by taking more complex combinations 13, 14, 15. Ensemble methods are able to improve the predictive performance of many base classifiers. In this paper, we consider ensemble learning technique, and apply them to SVM and decision tree algorithm. Voting classifier. Voting ensemble or a majority voting ensemble is an ensemble machine learning model that it combines the predictions from multiple models. This technique is used to improve performance model and achieving better performance than any single model used in the ensemble. A voting ensemble works by combining the predictions from multiple models. V results. The following table 2 shows prediction for heart disease. 6. Conclusion and future work. This project proposes a system to identify the best machine learning model in the prediction of disease. In this paper we have studied the different machine learning algorithms. We have analyzed different attributes related to different patients and predicted the accuracy for different machine learning algorithms, and the focus is to establish a healthcare prediction using machine learning algorithms that takes into the consideration of support vector machine and decision tree. Support vector machine and decision tree are used to predict heart disease. And ensembling of SVM and decision tree are done. From experimental results, this work concludes ensemble model is considered as a best algorithm because of its high accuracy. The system predicts the heart disease if unknown sample is given as an input by the user, and the doctors can attend to more patients, and this device can reduce the workload of medical personnel. In the future, application developers should work together with healthcare professionals and researchers to deliver disease apps which improve healthcare system.